সবাই জানে তো আজকে ক্লাস হবে, রাইট? ও
Yes, sir.
আচ্ছা, we'll be waiting for them to join.
Sir, you can post on the Google Classroom as well, so that those who forgot can join.
I think I had actually posted that on probably on Sunday. We had class, I couldn't take that class, and I posted on the classroom, right? Probably.
Yes, sir. Yes, sir. Yes.
We'll be waiting for other to join, and then we can start right away. Sure, go ahead. You can ask any question or problem. Somebody actually raised hand.
Sorry, sir, it's mistakenly.
Oh, all right, no problem. So hello everyone, welcome to the Triple 203 again. Once again, we'll be having our first class today. Means the we'll be discussing about the electrical circuit 2. So some people actually call it alternating circuit as well. So I think we have enough participant to start around 16 right now, but the number should be up to 35 or 40 maybe. I forgot the total number of actually students enrolled in this class. So maybe I can present my actually screen. Am I audible? Is my actually voice clear? Like, can
Yes,
you
sir.
hear me?
Yes, sir.
Because I'm
Yes,
in
sir.
my home, so I don't know. I have the better facilities on that. So this is the best I could do. If you couldn't hear me, so please right away let me know so I can actually turn off my fan. So you all can actually see my PDF file, right? Hello.
Yes, sir.
Yes,
Yes,
sir.
sir.
Thanks so much. So before I actually start my lecture, I had taken other courses, and after the classes, few actually student um, like told me that they are not actually quite okay with the lecture delivering in English. Rather, I should actually go for Bangla sometimes. So what do you prefer? Like, should I actually go in English or the hybrid system?
Sir, English is good.
English is
Yes, sir.
good.
English is good, sir.
It's good for everyone because I need the majority, you know, for
Sir,
making
I
a
think
decision.
you can switch your language whenever it's needed.
It's needed, right? All right.
Yes, sir. In
So
some special cases.
it's fine. So what I expect from all of you, like if you don't understand some terminology or some explanation, which would be provided in English, so please right away ask your question and pose your question in Bangla. I don't mind. Okay, I'll try to explain in as simple word as possible. Okay, so maybe we can start. We have enough participant actually. So this is our first actually slide, not slide, the PDF. Now the question is like probably in EEE 101 or 101, you all have learned about the DC circuit, right? Like direct current circuit, or where the current doesn't change. So here we'll be studying the same thing, probably with different types of actually sources, like the current source or the voltage source. Are not DC in actually nature, means it will change, and we call it actually alternating current, or in actually short, sometimes we call it AC circuit, but that AC doesn't mean air condition. So what is actually alternating current, or alternating signal, or alternating system? So as the name actually suggests, the alternating means something has to be changed. I don't know why everyone is actually asking to admit them to join our meeting. I have sent everyone actually the request why they should actually accept the request. So I don't need to actually admit them every time.
Sir, I think they're joining with their personal email. That's why.
But I asked all of you to provide the Black University email address so that I can add you as guest. Okay, if you have not done it yet, please actually go to Google Classroom and provide your email address and ID there. So I will actually send you an email on Google Calendar, perhaps. Okay, let's back to actually the slide. So what I wanted to say is alternating current means something that changes with respect to time. It doesn't like remain constant, just like the DC. So before I actually like define alternating current rigorously, we should actually learn about two other terms. Sometimes we call it oscillating system, or oscillating signal, as well as another thing is called the periodic signal. So what is called oscillation, or the oscillating? The oscillating current or oscillating signal is something the value of which alternately increases and then decreases with respect to time, but it doesn't follow any pattern. It only increases and then decreases randomly. But however, there is another term is called the periodic current, or the periodic system, or periodic signal, whatever we say. So this is a part of actually oscillating current, means it also changes. It also actually increases its values and then actually decreases again with respect to time, but it has a special pattern, means after a certain time period, it will be repeated. So there are many examples of it in the periodic system in our life. Like, let's talk about a floor with lots of actually tiles. So if you look at the arrangement of tiles, after every distance, like certain distance, we'll be finding the same pattern of the tiles or something. So this would be called the periodic system, or the periodic signal, or the periodic current. Means it's a current, oscillating current that will be repeated after certain actually interval. So in order to understand this term, especially the oscillating current and the periodic current, we may actually look into some actually diagram. So before that, now once we come to know about oscillating current as well as periodic current, we can define the alternating current rigorously. So what is the definition for that? In order to be an alternating current, any system or signal has to actually fulfill two basic criteria. One is that has to be periodic in nature, and the second one is the average value over a period has to be zero. That means the area on the upper axis, or the area on the below the x-axis has to be equal, but in opposite sign, so these two will cancel out. We'll discuss it in details actually later. So if you look at the certain graphs, these graphs are called waveform. So if you actually represent or draw anything with respect to time, then that graph would be called another special term. It's called the waveform. I think I need to again look something. Sorry. So if you look at the first graph, this is an example of oscillating current. It changes its value with respect to time. So if you look at this signal here or the current here, it changes, means it increases and then decreases, then increases, again decreases, increases and then decreases, but it doesn't follow any pattern, which it doesn't actually repeat after certain interval. So this one would be called as the oscillating current. It just oscillates. It changes its values, or it changes its like the slope or the direction as well. But how about other system? We talked about like the periodic. What does it mean? Periodic means it has to have a period, means like it has to be repeated after certain time interval. So if you look at this, it looks like a sine or cosine wave. So after certain actually time interval, it will be repeated once again. So if you look at this graph, if I actually keep on actually drawing it, then it will be just repeated like this. Maybe I can draw a bit. So if I actually keep on actually drawing this line, it would be something like this and this. Yeah, forget about my handwriting. So if you see closely, if I come here, draw a line, it will be actually repeated again. Is it true? No. Like if I draw a line here, this is wrong. This line is wrong. So what can we see? If I draw a line here, if I draw another line here, so you can see this line or this graph or this signal, it is increasing. It reaches to a maximum value. So this is called the maximum value. This is called the maximum value. From the next class, probably I'll be using another actually laptop, so where I can write easily. Right now I need to write with my mouse. So and so this is the actually minimum value. So what we actually have seen, so this is a signal which start from a certain value, then it reaches to the maximum value, and then actually falls down to minimum value, and again it gets actually repeated after a certain time interval. So this time would be called a time period. Sorry, this is a capital T actually. This is called the time period, like the minimum time it requires to actually repeat the signal again. So the time period from here, the time required from here to here, propagate the signal, is equal to this like signal propagate from here to there. So these two times actually are equal. So, but we have written this is not AC, and why this is not AC we'll actually discuss later. Now, if you look at other actually two figures, this figure is symmetric around the x-axis, means the pure actually sinusoidal wave or the sine curve or the sine x. This is the graph of sine t, because we are plotting against actually t. Or this is an example of square wave. It is started from 0 and then goes to the maximum value, and this goes down to the minimum value, and then actually gets repeated. So whatever the value here, the maximum value, let's say this is EM, this value is also negative EM, means the value is the same. And how do we actually measure that value? We will always use the x-axis as the reference. So this EM is measured actually with respect to this point, and this EM, or the maximum value in the negative side or the lowest point, can be actually measured from here. So now the same applies for the square wave. Now, why are we actually calling it as AC or alternating current, but this one is not alternating current? As I mentioned earlier, in order to actually define an alternating current, the two conditions has to be fulfilled. What are the two conditions. The first condition is it has to be a periodic system, and the second thing is the average value of the periodic system over a period. Over a period means the minimum actually time required to complete a cycle has to be 0. So let's check, does it actually fulfill, are this actually fulfilled or not? So if you look at, the first criteria, yes, it's a periodic system. So because it has started from here and then it's finished here, and then we get another actually new signal. The same signal is getting actually repeated. Same applies for, this signal. If I check here, it goes to the maximum value, then it goes down to, the minimum value, and then again it gets started from here. So this is a periodic signal for, there is no confusion about it. Do you have any confusion that these two are periodic signal?
No,
Any
sir.
question?
No, sir, no
No?
problem.
No, sir.
Okay. Yeah. All right. So now the second actually criteria has to be fulfilled. So we need to check the average value for this time period has to be 0. So how would we actually measure, average value? There are, many ways. So the easiest way to check is we need to actually calculate the area with the graph with respect to, the x-axis. So if you look at the area for a time period, the time period is starting from here and finishes actually at here. So this is, maybe I can change, the color. So what is wrong? I don't know, something is wrong. So so if you look at, the actually color here, I think I can change the color. Just give me a second. The color can be changed, right? This color is good. So if you look at the area, then we can measure, the area here. Let's say this area is A1. Someone is requesting again. Yes, I have added it. And then the area for, the other cycle, half cycle, is this. Since this two has the same actually magnitude of the maximum value on positive direction and the negative direction, if the area for this actually half cycle is A1, then the area for this one has to be A1 too. But this is positive area, this is negative area. So that's why I used the negative sign. Somebody actually may actually pose a question. Oh, area cannot be in a vector, means area is always a scalar, so I cannot put in the negative 5 in front of it. Yes, that is true. But if you want to actually measure, the what is it called, like the average value, then what we will consider is the direction. So since the current in this direction is positive and is in this direction is negative, so if I actually take the integration, then there will be a negative sign for, the negative actually current. So since these two areas are equal, if I actually sum up, these two, if I sum up these two, what I will get is 0. So the total, area has to be 0. So this is one of the reason. This is called actually AC signal. Same applies from here. Whatever area you will get for the positive half cycle, you'll get the same area for the negative half cycle. But for the positive half cycle, the direction of current is positive, but the direction of current for the negative half cycle is negative. So the total area would be 0. Now I have a question. That will be verifying it in a letter probably. So if you look at this, the question proposed, where is the question? Yeah. So the question is it possible to verify the average value for the sinusoidal or the sine curve is 0 for a given period? Okay, I'm giving you a hint, and later on we'll discuss again. Since this graph can be actually represented by a sine wave, let's say this sine wave would be Em sine t, because this is varying actually with respect to t. So if I actually integrate over 0 to capital T, we'll see the integration will go to actually 0. Means the total actually, the area or the average value will be 0 over a period. Later on, we will actually verify this one, because we don't know, some certain terms like how to represent, this graph or this signal with in terms of actually some sort of equations. We'll be actually discussing.
Sorry, is it because sine 360 is equal to 0?
No, the thing is, whenever we say sine or cosine or the sinusoidal, so some people actually may think, oh, sinusoidal means sine only. No, sinusoidal means either it can be sine wave or the cosine wave, and sine wave can be actually converted into cosine wave, or the cosine wave can be actually converted into sine wave, or the vice versa by just changing some offset. But as we all know, sine and cosine, these are actually periodic signal. So if you all integrate over a certain period, you'll always actually end up with getting 0. I will actually show it in a letter. I need to explain certain terms actually first. So these are the basic things about the AC circuit. Now, if I come back to the previous one, although it looks like the same, why didn't we say, oh, this is not AC? Now we can verify it. So if you look closely, this is definitely a periodic signal because it's getting actually repeated. But this is our the reference point. So if this is our reference point, what is the area we can calculate? What is the area we can calculate here? So you check for the first half cycle, the area is given by this, and the negative half cycle area is given by this. So for this actually half cycle, let's say area is A1. For this one, area would be A1 again because it covers the same actually like area, although it doesn't look the same. It's because of the handwriting. But the problem here is if you look at the current here, the direction of current is positive, right? The direction of the current is positive here also. Means the current current didn't actually change its actually direction. So if I add up these two area, we'll ending up actually getting 2A1 rather than getting 0. Am I clear?
Yes,
If
sir.
you have any
Yes,
question,
sir.
you may actually ask me another question. Since here, the current is not changing its direction. Direction means, the positive to negative or negative to positive. Because here the current is positive. Here the current is again positive because the whole actually graph is situated on the, the first, the quadrant, right? This is the positive quadrant. This is the negative quadrant for, I. This is the positive t. This is the negative t. Although, there is nothing called, negative t. Time cannot be negative. So this is the whole reason. Reason actually this is a periodic signal, but not alternating actually signal. And here, the two conditions are fulfilled. This is a periodic system as well as the average value is 0. So we can actually call it a AC signal. So I hope you understood this part. Now, in order to understand the whole thing, whatever I have said in terms of actually electrical circuit, how would we actually represent the DC signal and the AC signal, and how does it actually change the certain electrical properties in a signal or in a system, electrical circuit or system? Let's talk about something like look at this actually circuit and look at this circuit. What are the differences? There are the differences is here the current source is a
DC circuit.
Yeah, it's a DC. But here you see is there is something like this. This represents a the sinusoidal, just like a sine graph. So this is given by this is again a current source that I, then it's a function of t. That's why it is written in that way. Sometimes we just write down a small I, or sometimes we write down I, the function of t equal to 5 sine t. What does it mean? We'll explain it later. So first, this one is a DC source. It means it doesn't actually change with respect to time. It doesn't change with respect to time. That's why it is called the DC circuit or the direct circuit. Means the current is always 5 ampere, no matter what time have we selected. Or in the contrary, this circuit is represented by a AC source. Means this current source will be changing its value as well as direction with respect to time. So if I change our time, then you will see this value would be positive for certain time interval, and then it will be negative, and then it will be actually getting repeated. So the two actually condition will be fulfilled, the periodic as well as the average value will be 0. So that's why this is called AC circuit. Now, if I actually fed a AC circuit or the AC source into a circuit like the basic circuit with a resistance, nothing else. So resistance, how does actually the resistance behave? Like the current flowing through resistance or the voltage across the resistance, how does it look like? In order to do so, we have just plotted this 2 as a function of t, means this is the waveform. So since the first one is a DC and the maximum value is 5, it will be always in a 5 ampere, no matter what time have we selected. But as I said, for the AC source, it's a 5 sine t. That means it would be a sinusoidal wave, whose actually maximum value would be 5. What is the maximum value for sine or cosine? Can we actually, can you tell me?
Sir, 1.
1.
What is the minimum value?
Minus 1.
0. Minus 1.
0? No,
Minus
negative
1,
1.
sorry.
Yes, negative 1. So how about the cosine? What is the maximum value for cosine?
Sir, both are the same.
1.
Plus 1,
1
minus
and
1.
minus 1.
Thank you so much. So
Yes.
if the maximum value for sine t is 1, then what is the maximum value for this system? 1 times 5, right? So whatever is here, it would be the maximum value. Means if I write down this is x, so maximum value is x. If I write down maximum value is 1 million, the maximum value would be 1 million. For our example, the maximum value would be 5, and the minimum value would be minus 5, because the maximum and minimum value for the sine t is 1 and negative 1 respectively. So if I actually draw the signal, since this is sine wave, it will start from 0 and then up to 180 degree. 180 degree, when I say is in terms of actual phase. In terms of time, it looks like this, like till a certain time, or the half cycle will get positive value, and then another half cycle will get negative value, and then it will be actually repeated again. So the whole thing is called time period. The whole thing will be called a time period. Do we know about time period? We'll be discussing again.
Yes, sir.
Yes,
Time
sir, we
period
know.
is the time that a waveform took to complete one full cycle.
Yes, perfectly. So like at this point, we can call it.
So
half
have we regarded this in this equation that 2 pi f is equal 1?
For this one, twice pi
5
f
sine
means
t.
Yes, yes,
2 pi f equal 1.
yes.
Okay.
This is the easiest example. That's why I didn't actually incorporate anything here, because as he actually mentioned, the general expression for the AC source should be a bit different. Later on, we'll be learning. There would be some some term here, or maybe there will be some offset. Later on, we'll be learning. So this is called half cycle, because this time, the time required from here to actually here would be exactly half of the the full cycle. So if you look at the graph changes its direction as well as the magnitudes, right, depending on the time. So if I draw in the circuit, this is the waveform. But if I draw a circuit at different time, let's say we have considered certain actually time point, like at t equal to 0.5 second or millisecond. Someone is joining right now after half an hour. So we'll be considering 3 or 4 different actual points. Let's say this point at t equal to 0 time. This is the point. This is the point. I don't know. Randomly we have selected, let's say 0.5 second, and the magnitude is 4.2, because the maximum magnitude has to be 5 here. So here the magnitude has to be 5. Here the magnitude is -5. Same applies for we consider a time period here. So at that time period, at that time of 1.5 second, the magnitude goes to 0, and again at t equal to 1.5 second, the magnitude again goes to 0. So that means we are considering 4 actually different points. Let's actually draw the circuit. So at t equal to 0 second, if you look at this one, the DC source is 5 ampere, right? Because it doesn't change with respect to time. But for the AC signal, the magnitude will change with respect to time. So at t equal to 0, what is the magnitude for the AC source? Is 0, right? But for the DC circuit, the magnitude for the current is 5 ampere. So if I draw the signal at t equal to 0 second, and if I actually connect a ammeter in series, what would be the reading for the ammeter? Since this is a DC, no matter what time we are selecting, will be always actually ending up getting actually 5 ampere. But for the AC circuit, we'll be getting 0 ampere. Why? Because at t equal to 0, the magnitude for this current is 0. So if this goes to 0, there will be no current flowing through the resistor. Now, if I actually get back to t equal to 1.5 second, let's say 1.5 seconds. So at 1.5 second, again what is 0? The AC source is 0, right? At t equal to 1.5 second, the magnitude for the current is 0. But for the DC is again the 0. DC value is 5 ampere. So we'll be actually getting a signal like this. We'll be getting 5 ampere for the DC always, but for the AC again we'll be actually getting 0 ampere. But at the other point, let's say at 0.5 second, if we consider magnitude is something less than 5, let's consider the 4.2 ampere, then we'll be getting actually 4.2 ampere current flowing through this resistor. But how about this point? At t equal to 1.8 second, you see the magnitude for this current is -5 ampere. So for the negative 5 ampere, what does it mean in a current? Like
Sir,
changes its
direction, right?
Changing its direction.
Yes, sir.
So
From the negative side, this time the current is coming from the negative side of the source.
Yes.
But in DC source, it is always comes from the positive to negative side.
Yes, thank you so much. So for the DC source, if I'm not actually wrong, it has some sort of polarity, right? That means current
Yes,
will
sir.
be always flowing through this direction to that direction, means the what is it called, clockwise direction. So for the DC, it will be always actually flowing, for this actual example, on the clockwise direction. But however, for the AC circuit, with time it can actually flow in the clockwise direction. Here it is actually flowing in the clockwise direction. Here it is actually flowing in the anti-clockwise direction. Do you understand this? Like how this is changing with respect to time?
Yes,
sir.
sir.
Okay, thank you so much. So what conclusion actually can we make? So in case of DC, the value is always constant because the name suggests the direct current, it doesn't change with respect to time because it has no time dependence. Can you give me some example of DC voltage or DC current? Do you have any idea? Like it doesn't change with respect to time?
Sir,
So
can you
battery?
What sort of battery is this?
So battery doesn't change.
Yeah,
It's according to time, I think so.
yeah, this is
Yeah.
correct. Yes. So how about the AC? So in case of AC, the value of current changes, even the direction of current changes actually as well, depending on which cycle the time fall into. Like if we consider the first half cycle, the current will be positive. For the next half cycle, current will be negative, and then again the third half cycle, current will be positive, and then negative, and so on. It will be repeating again and again. So now the question. Yes, sure.
Sir, I had a question.
Yes,
Sir,
sure.
can you please explain the magnitude for t is equal to
0.5.
no, for the time period, half of the time period, I mean t/2, capital T/2.
Okay. All right. So since it's a sinusoidal wave, it will start from 0, and then it will actually goes to 0, and again it become actually negative, and it goes to 0 again. Since this is the full actually time cycle or the time period, so what is the half period from here to here, right? Let's say this is 10 seconds. So the time required to travel the signal from here to here should be the 5 seconds. So that's how we are writing t/2. So
Okay, sir. Okay. Got it. Thank
so,
you.
thank you. No problem. So these are the actually certain definitions. So we use the this sort of actually signal, sinusoidal signal everywhere. In Bangladesh and Europe, we use actually AC currents of I think 50 hertz.
Yes, sir, 50 hertz. And in
50 hertz.
America, it is 60 hertz.
America and Canada probably they go for the 60 hertz. Means
Yes, sir.
every second that the signal there will be at least 50 signal, like 50 such signals
Cycles.
or the cycles will be per second. Like there will be 50 signals per second. So these are certain things. So I do understand you probably are familiar with certain actual basic definition, but I may actually review it again for your refreshing in the memory. So so if we have like alternating current of the AC current, by definition, most of the cases will be getting actually alternating voltage, or vice versa. Means if we actually like apply some alternating voltage in a circuit, and if there is some resistor or inductor or capacitor, we're supposed to get the alternating current. Although the current behavior and the voltage behavior might be different, we'll be learning this behavior in this actually course. So before that, we have to be very clear about certain terminologies, like that would be repeated in the whole actually course. So as we actually have learned the basic, the like signal, AC signal should be look like this, right? So something should be like this. So there are certain actually definition. So since it's an AC signal, most of the cases we will be plotting against either time or with respect to the angular like phase or something that we'll be learning it later. So angles. So if we plot against time, then that function, whatever we are plotting, it has to be a function of t. So how do we actually distinguish DC and AC? So generally, the DC, we represent the voltage with capital V. We represent current with capital I. We represent actually instantaneous actually voltage or something with capital E, or electromagnetic force or electromagnetic actually sorry, EMF. So sometimes people call it electromagnetic force. Sometimes actually they call it the battery cell or something. So everything actually explained or the represented in terms of actually the capital letter. So it is in DC. But in AC, so all voltage would be represented by small v, current would be represented by a small I, and instantaneous actually voltage would be actually represented by a small e. Sometimes people actually write down like this. Oh, this is a function of time. But sometimes they don't write, like they just discard that time dependence part. Since it's a small letter, we can understand, oh, this is a time dependent part. So here is an example of such actually alternating current. This is not alternating current, actually it's alternating voltage or something that changes with respect to time. So as we have already learned, it has started from actually 0. So it will actually go up to a maximum value and then again actually fall down to 0. Then it changes its direction, means from here to here is positive, but from here to here it would be negative. It will actually goes down to the minimum peak, or minimum actually value, and then again goes to 0. Then it will be repeated again. So there are a few terms like we need to know. One thing is called instantaneous value. What does it mean? It means the magnitude of that alternating signal or alternating current or voltage at a given time, at any time. Let's say the full time period is 10 seconds, not 10 seconds actually, maybe millisecond. So I say, oh, what is the value of the voltage at 1 millisecond? Like let's say this is 1 second. So instantaneous value means the value of of that alternating signal at given time, means at any time, means E1 is the actually instantaneous value at time t1. Em is the value at let's say time, this is time m. So Em is the instantaneous value at Tm. Here the instantaneous value is 0, so is the instantaneous value 0 at, let's say, Ts. So this is the value at Ts, the instantaneous value. So instantaneous value just represent the value at any given point. But there are certain other terms we need to understand. So something is called peak value. The peak value means the maximum value with respect to the reference. So when we call it reference, which one is called reference? Reference generally is represented by the x-axis. That means like e equal to 0 line. This line is represented by e equal to 0, right? We have learned in HSC probably, right? What is the equation for x-axis equation? What is the equation for x-axis?
Y is equal to
right?
0.
So what is in the y direction now?
X.
E, right?
X is equal to 0.
So I know, but what are we representing in the y direction now? E, right? So the equation for this x-axis has to be equal to 0. If it was y, then we would write down y equal to 0. Am I clear?
Yes, sir.
Thank you so much. So the maximum or the peak voltage or the peak current should be measured from the reference line or from the x-axis. So whatever the value from here to here would be called the peak value. So there is another thing is called negative peak value. So from the reference point to the minimum value of that signal would be called negative peak value. Since it's a AC signal, this peak value and this peak value would be equal. Otherwise, the area would not be equal for the positive half cycle and the negative half cycle. So if this is actually EM, this one would be also EM, but negative value. Let's say this is 5. Then this one would be also negative 5. Do you understand this? Like what I wanted to say? Hello.
Yes, sir.
Yes, sir.
Thank you so much.
Yes, sir.
So there is another term is called the peak-to-peak value. Peak-to-peak value. P stands for peak. So peak-to-peak value means what is the value from the negative peak to the positive peak. So the difference between positive peak to negative peak would be called the peak-to-peak value. For our actual example, what is the peak-to-peak value? Can you actually tell me?
10.
Is it
5
0 or
to
10?
minus 5.
It's 10, I think.
5.
Sir, it will be 10.
So
Five
10,
times
Sir,
right?
five.
it will be
Yes.
10. 5
Thank you so much.
minus 5.
Yes, thank you so much. Yeah, whatever I said, is written here, so you can actually just check it out. So now I have a question, although it's not so straightforward. I want to interact with this. I have drawn something like this. This is my time, and this maybe I can change the color. From here to here is again 5. Again here to here. Sorry, this is negative 5. So this 5 is measured from this reference point, the dotted line. And this is, let's say, called 10. Oh, my handwriting. Inshallah, from the next class, I will be using a pen. It's not actually readable, right? 10. All right. Oh, okay.
So you've written 10, right? Okay.
Yeah, thanks. So now can you tell me what is the peak-to-peak value for this signal?
Sorry, it's not an
Sir, it's not an
already
AC.
current.
Sir, it's
No,
not.
it is
So I
an
know.
sir. Now the peak value shall be at the positive side. It will be 15, and then
Negative
in
side will
the
be 5, right?
negative
So the
side.
peak to peak value will always be 10 actually.
Yes. Whoever is like saying the peak to peak value it would be always 10 is correct. Yes, it's not an AC signal, right? But it's a periodic signal, so we can measure this actually quantity. Now tell me what would be the peak value only, positive peak value.
Yes, sir. I have
Positive
said that.
peak value would be
15.
15 and the
Sir,
negative peak value would be
15.
5.
Yes, and negative peak value would be 5, right?
5.
5.
Um, how about others? Like, do you have any other opinion?
Yes, sir.
You
Sir,
all
the
agree with
signal,
this?
sir, the signal is not going in the negative direction, so
Yes.
the negative peak value would be 0.
How about other students? Like I believe only few students are interacting. Other students are sleeping, having lunch, or something. I don't know. You are free to actually interact, even if you are wrong. I don't mind. Okay. So I think yes. So the answer is correct. The peak value for positive positive peak value has to be 10 plus 5, and the negative actually peak value would be 10 negative 5, so equal to positive 5, because the definition by definition the peak value has to be measured with respect to this line. The reference line means when like x-axis you need to measure with respect to x-axis. So from the x-axis the positive peak value would be 15 and the negative peak value would be 5. So be
Sir,
careful.
aren't we considering the x-axis as the reference line, or is it the resultant line that you have drawn between here?
Okay, we have actually two reference lines. So when we actually say we are going to measure the peak value, we must to consider the x-axis as the reference point. But if you are going to actually look at the symmetry of that system or decompose the whole system into DC plus AC, actually this is a AC signal plus a DC offset. Later on we will be actually discussing it. End of this class, actually there will be some example for this.
Yes, sir.
So, yeah. So yeah, we need to measure with respect to x-axis if we want to actually get the peak value positive and the negative peak value. So yeah, and do you have any actual confusion about the period, like the minimum time required to complete a cycle? No, probably
No,
not.
sir.
You all actually know that. Yeah, I should not spend time on it. So what do you mean by frequency? The number of the complete cycle that occur in a per second. So this is nothing. The frequency is the reciprocal term for the time period. So f equal to 1 upon t. We all know that. Now the important question arises. Like, there is another term. It has to be very clear to everyone. It's called phase. So what is called phase? So phase is a fractional part of a period through which the time or the oscillated time angle has advanced from some arbitrary references. Maybe it's quite complex definition. The easiest.
Sir, can you please
Yes.
repeat
I will.
this,
I will actually make it simple. Like, I will simplify it. So the phase represents. Maybe I can actually go back to the figure. So just think about you are in a race, like 100-meter race or something. So this is your starting point. So if you are starting actually from the reference point, this means there is no phase here, like you are just starting from here. But there are few other actually runners who are starting from here, but they are running in the same way. Running in the same way. Or there will be other actually runners who are running. Maybe from here, but in the same pattern. So what does it mean? Like someone is running from here because this has to be the reference point, and some other is running from the behind, and some other is running from the actually some certain distance ahead. So that means the phase for this one and the phase for this one are not the same. What does it mean? If I actually plot it in terms of actually angle, because it's we are representing so far, the AC signal with respect to time. We can also, represent, an AC signal with respect to, angles. What sort of angle? So if you look at, the AC signal, something like this, what is this angle? 0, right? What is this angle if it is the complete period? 2 pi, right?
0.
2 pi.
Yes.
2 pi or 360 degree.
2 pi.
So generally we use radian in electrical circuit. Whenever we say the angle, we'll try to actually like represent in terms of actually radian. So can you tell me what is the phase here?
Sir,
Pi
what?
by. Sorry, pi.
Pi, right?
So there's just
All right. So if we actually plot, like the signal with respect to angle, means not t, maybe with respect to theta angle, then we can see, oh, if I draw, something here, same signal, same pattern, some signal will be starting from not 0 angle, right? Some
Pi by
would some signal, we don't know that angle. Let's say this is pi by 2. So this one is actually starting from pi by 2. Similarly for here, if it is actually starting from here, maybe it is starting from negative pi by 2 or something. So that offset, the starting offset, is called the phase. Like the rigorous definition is given here. Like for a sinusoidal waveform, the phase denotes the corresponding angle at any time period. Like if you want to actually calculate an angle, then that angle would be called the phase at that given time. So quite random things. I will actually give you an example so you will understand.
So in a real life example, what is actually phases work? So then is it like if the difference is too much, then the bulb will burst or something like that?
This is how you actually design the system. So you can define the system. So let's actually talk about this a bit. So let's think about a signal. That signal is like this. Then sine, let's say t, or alpha t. Actually, this is not t, alpha times t. So I say,
Sir, alpha is equal to omega t, sir.
Yeah, we'll define omega later. Since we have not actually discussed about omega, I didn't actually put. Let's say at t equal to 1 second, the instantaneous value of the voltage is 3 volt. So if I actually substitute the t value here, means my target is to calculate what is the phase of this actually AC signal, because this signal would be looking like this, right? Am I right? This, if I draw this signal, it will be looking like this. The
Yes,
maximum
sir.
value would be 10, and this one would be the negative 10, right? The question about this. Now I said at 1 second and certain point, maybe I can change the color. So at this point, this is, let's say, t equal to 1 second, and the magnitude is 3 volt. I say, what is the actually phase at this point? At this point, what is the phase of that signal? Because this is not starting from the 0. So if I draw, right now this is plotting against actually time. So if I draw the same thing with respect to phase angle alpha, how does it look like? Means what is the phase angle here? So what I have to do, we'll substitute the value of t and the voltage value at that given actually time here. So if I actually plot t equal to 1 here and v equal to 3 here, we can easily calculate alpha, right? We can easily calculate alpha. That alpha would be called the phase of that sinusoidal. So generally it is represented in terms of actually radian. So do you have any actually question about it? I don't have in the calculator, so if I substitute this one, so alpha would be, alpha would be sine inverse 1 upon small t, then sine inverse, then small v divided by 10, right? If I solve this one for alpha, then we'll get something like this. So if I replace t equal to 1 and v equal to 3, we'll get this angle. I don't know, maybe this angle would be something like 10 degree or something. So 10 degree, but we never actually represent like phase in terms of degree unless it's specified. So electrical angle means always in radian. So we'll actually prefer radian. We can actually convert degree into radian. Do we all know how to convert degree into radian, or I need to actually tell?
Yes, sir.
No, sir, we know it.
Pi
Oh,
by
I know
1.
it.
Okay.
Okay. So the relation is 180 degree equal pi radian, right? If I'm not wrong. Am I right?
Yes, sir.
Yes, sir.
Yes. Okay. So something like this. So we can actually change this thing. So this is called phase. Like what is the angle at given in the time? So that represents the phase. Okay. So now the term comes like angular frequency. What do we mean by angular frequency? So from the physics we have learned in the HSL level, the angular frequency means the angular velocity, sometimes people call, is defined by the angular displacement divided by time. Just like the velocity equal to distance divided by time. Angular frequency means angular displacement. Angular displacement means this is the angle. This is the angle divided by unit time. So omega, or the angular frequency, should be something like this: the angle divided by time. This is a new definition. There are other definitions that you already know. Omega equal to 2 pi f, f equal to frequency. So we know f equal to 1 upon capital T, right? The time period. So if I replace this one, then we'll get omega equal to 2 pi by capital T. So these relations are so important for evaluating the nature of the sinusoidal actually behavior. Now, I asked you a question in the beginning, something like this. If I have a sinusoidal wave, this is just time. So this time would be called capital T. Capital T. Let's say this is a voltage signal, and the maximum value is, let's say 10. So this is negative 10. So can somebody tell me, or can you actually verify this? The average value for this sinusoidal signal would be 0. Is it possible to verify?
Miss, I mean, sir, could we integrate this?
Yes, sure. Yeah, we need to
So
integrate this.
Yes.
So those who don't know how to do that, maybe I can show you. So what is called average value? Let's say we want to calculate average value. So B bar means the average value. We need to integrate the whole thing over a period. So what is the actual signal? What is this signal? Like, what is the maximum value? 10, right? And it has started from the 0. So this is the 0 point, reference point. So this is nothing but a sine wave. And what is here? It has a angular actually velocity or angular frequency, because it's moving in certain direction. So omega, and it's changing with respect to t. So it would be something like this, omega t. And we need to integrate over time, right? Because it's changing with time. Now, when I say average, we need to actually divide with respect to the time period. So time period is 0 to t, means capital T. Can you tell me what is the limit for this integration?
Plus 10 and minus 10.
0 to
10
2,
0
minus
to cap.
2. So 0 to 2
Okay.
pi.
minus 10 to 10.
So
0 to t, sir. 0 to
0
2
to t.
0 to t.
0 to 2 হবে, sir.
Thank you so much.
Time.
Thank you so much. Now, yeah. Whenever I have said actually, negative 10 to 10, look, we are changing t. So we need to calculate what is the value of t here and here. If we had written down, this is dv, then we'll be writing down, negative 10 to 10. Am I clear? it depends on the difference integration variable.
Yes, sir.
Yes, sir.
Yes, sir.
So now can anybody actually give a try like the integration would be 0? Use this relation t equal to 2 pi by omega, or omega equal to 2 pi by t. If you are like not joining from the mobile phone or something, and if you have some piece of paper, you can actually give a try for this integration and check whether this is 0 or not. Am I right? Integration? Oh, there should be 10, right? So if I actually substitute the t value here instead of small t, capital T, so omega times t equal to 2 pi. So you'll see in the cos 2 pi means 1 minus lower limit, cos 0 means 1, 1 minus 1 means 0. So if you give a try, you will get 0. And if you still having some issues, you can actually talk to me later on. So you will get 0. So average value for this sort of actually sinusoidal is 0, and it's a periodic signal. So this system should be called the AC circuit or AC signal or something. Am I clear? Later on you can try. We can actually go to other things. So there is an example. Sorry. So if we have a sinusoidal actually signal like this, so we actually calculate many things like it's a signal, so it's just a sinusoidal signal. So can we calculate what is the peak value? It would be an example. There is given everything is given here, but at home you can actually practice.
8,
I will
sir.
upload everything. Yes. So the peak value is 8 because it has started from the x-axis, right? So the peak value is only from here to here. What is the instantaneous value at 0.3 second and 0.6 second?
Sir, 0.
So look,
minus
thi-
8 volt.
yes, yeah, this is 0, right? And this is the full cycle, 0.4. So this is 0.2. How about this? What is this point? 0.1, right?
1,
How about this? 0.3.
3,
What is the value at 0.3? The negative 8 volt,
minus
right?
8 volts.
So the instantaneous value at 0.3 second would be negative 8 volt. And how about 0.6?
0.
0.
So here the 0 you all know. All right. What is the peak to peak value? Then I
16 volts.
16 volt.
because 8 volt on the top and 8 volt negative 8 volt in the bottom, so the difference should be 18 volt. Now what is the period of this period? Means the time required to
0.4 seconds, sir.
so 0.4 second. Do other actually students understand, or only the few students are understanding why this is 0.4? So this
Yes,
is the
sir,
time
we are
period because it starts from here. It goes to maximum value, then goes down to minimum value, and then again comes to 0 because this is 0. It has again come to 0, and then we start the same graphs again. So some other people actually may measure from here. Means this is the reference point, this is the finishing point. So 0.8 negative minus 0.4, you'll be getting the same values. Or some may think, no, we are bit smart. We don't actually do it in the right way, like not the straightforward way. So some may say, oh, this is my reference point. If this is their reference point, which one would be their ending point? This one, right?
0.6.
Because it's going down. Here also it is going down. So what is the difference? 0.6 minus 0.2 equal to 0.4. Since it's a periodic system, no matter how we measure, the quantity will be ending up actually getting the same actually values unless you make mistakes. So now the final thing that we have discussed in a few minutes earlier, if we want to discuss what is the phase angle at 0.3 second and 0.6 second, how will you calculate? Like 0.3 means this, right? And 0.6 means this. Can you tell me what is the angle here? Zero degree, right? What is the angle here? 0 degree.
Pi.
180 degree.
Wow.
180
No,
degree.
zero.
Here,
Oh, yes, pi.
here is the angle is 360 degree, right? Now tell me what is the angle here?
90.
90 pi by 2.
90.
90 degree.
What is the angle here? 270 degree.
Minus 9.
270. 270.
7.
Okay, 270 degree, and so on, right? So can we calculate what is the phase angle at 0.3 second? Yes, here is negative. Sorry, 270 degree, right?
Yes.
Yes, sir.
Okay, now interesting question is coming. So what is the phase angle at 0.6 second? Means here.
Sir, 180 degrees.
Sir, 180 degrees, sir.
Is there any other actually opinion?
স্যার এটা হবে হচ্ছে
360 plus
pi
180.
2 pi plus pi.
Yes, sir. 2 pi plus pi.
Okay. How about the other actually student like?
Sir, actually same. 2 pi.
Sir, do you want the difference
plus
or
pi
just
and
0.6?
pi 3.
So this is 2 pi, right? From here to here, and this is also another pi.
Pi. 3 pi.
So total
3
is
pi.
3 pi. Yes. If you consider this one as the reference. Okay. So now if somebody actually only like tell me, oh, now this is the reference, this angle would be only in the pi. But if we consider this one as the reference, then it would be 2 pi plus pi, means 3 pi. But everything after 360 degree, it will be repeated. So if somebody is writing, oh, this is 3 pi or pi, both are correct. Like depending on which reference are we actually considering. So this is one of the situation. Here are the examples, so you can actually check. We'll be getting the same results. Like, so how do we actually calculate here? For the angular frequency, we know the formula, right? 2 pi by capital T. So we know the value of time period is 0.4. So we just actually substitute that value. We can get the omega equal to certain radian per second. So now the phase angle at 0.3 seconds, what does it mean? Can you actually, do we know, what does it mean? The radian per second means per in every
Per
second. 15.2, I don't know, 15.71 radian it will travel, right? It will travel 15.71 radian per second. So how much will it travel at 0.3 second? So all I have to do is just to
multiply by
with
3.
this. So, but whatever we have done, we'll be getting the same values, no matter which method are we following. So, oh yeah, these are just the some definitions. Like why sinusoidal waveforms are so important, because everywhere we use it, and most of the waveform can be explained in terms of sinusoidal and the cosine, means sine and cosine waveform. I believe another thing is like these are very easy to actually transmit. Means if you are generating in Chittagong, we can actually easily transmitting the power or the signal in like Dhaka or other places. Like these are very efficient. And the other things are the real thing is like if we have some nonlinear actually like components such as inductor or capacitor in our system, still we'll be getting the same types of waveform. Like waveform doesn't change so much if we use actually sinusoidal or AC actually system. And the most important part is any signal, no matter what is that signal, square wave, triangular wave, or other types, any types of wave, if it is periodic waveform, that can be actually represented in terms of actually summation of many sinusoidal wave, means that there will be some sine wave, cosine wave at different frequency. But if I add up everything, we can always generate any types of actually signal. And this is called a very interesting series. maybe you have heard about it. Like this is called the Fourier series or the Laplace transformation or something, but you have not learned it unless in the third year or something. I don't know. What does it mean? If you have a square wave, means something like this. You have a square wave. Sorry, this is square wave. It can be generated using many sinusoidal waveform. The answer is how. Or if I have a triangular wave, something like this, we still can get actually the triangular wave using the many sinusoidal wave. So maybe you can actually check if you are interested, but that is not that easy and that is not so important. That's why I didn't actually show it here, but it can be done. Now, how to represent a generally the sinusoidal current or voltage. As I said earlier, it will be represented by the the lowercase, like lower I, lower e, or lower v. E and v both actually denotes actually the voltage, while I denotes actually the current. Since it's a sinusoidal, I can write down cosine or I can write down sine. It's up to me. There is no other differences. Whatever is applicable for sine, it would be applicable for cosine, unless we have this graph. Like this is the graph for sine. This is the graph for sine, and if I'm not wrong, this is the graph for cosine. Am I wrong?
No, sir, you are
yeah,
right.
Yeah, something like this, right? So this is the graph for sine, and this is the graph for cosine. These two will have the same shape. Only difference is certain phase difference. Means we always know that sine x equal to cosine pi by 2 minus x, right? Is it correct? Means we can always transform sine x into cosine or vice versa. So any sinusoidal current and voltage would be actually represented in terms of sine or cosine. If I don't actually mention anything, I suggest you all to use the sine term. So since it's actually AC sinusoidal actually current or voltage, it's supposed to have a maximum value that is given by Im or Em. M stands for actually maximum. And there will be two terms, is angular velocity or omega, and with respect to time, because it's a time dependent actually part. The whole thing at omega t would be called as the phase. Is that alpha that we have actually discussed in here, right? That alpha equal to omega t. The whole angle would be called the phase, and this is the angular frequency times time. So these are the representation of any actually general sinusoidal current or voltage or whatever we actually need. Now, as we have already actually discussed earlier, how to calculate that phase angle. So all we need to know what is the value at given, what is the value of the current or voltage at given time, and what is the maximum value if these two are given. In another way, we can calculate alpha if the angular frequency is given, omega is given, and the time is given. So all I have to do is just to multiply these two. If the angular frequency is given and the time is given, let's say 1 second or 2 seconds, so all I have to do is to just multiply these two in order to get the phase angle. So this is an example how to actually calculate the phase angle for the sinusoidal voltage. We can just calculate what is the value for alpha, and this value will be given. This value will be given. We can calculate the phase at certain point. Here is an example. I will just actually give an idea or hint. You may actually practice at home. So let's say I have a battery which is being charged actually by an AC source, and the equation is given by this. The voltage with respect to time, the maximum voltage is 15 volt, but with respect to time, this is omega, right? Because the general expression should be Em or the Vm sine then omega t. So if I actually consider it with respect to V of t equal to Pm, then sine, then omega times t. So if I compare these two actually equation, what is the value for Vm? 15, right?
Yes, sir.
Yes, sir.
And what is the angular frequency here?
377.
377.
7%.
Yes, radian per second, right? So they say the battery is charged only when the voltage is actually over 10 volt. What does it mean?
So it will charge.
Yes. Whenever actually this voltage actually goes above actually 10 volt, the battery will be charged, right? Because if I draw in this graph, it would be something like this, if I'm not wrong. So this is 15. This is 15. So what is my cutoff value? 10 volt, right? So I'll draw a line 10 volt. So this is 10 volt. If this is 10 volt, only at that time it will start charging, and it will stop charging again at this time, and then it will be repeated, here. So from here to here, let's say this is 1 second. So 0 to
Excuse me,
1
sir.
second.
Sir, when the value of y is negative, I mean in the lower
It
part,
will be charged.
sir,
Will be
but
charged again.
sir, but the current will flow in the different
Opposite direction. So
direction. But
so basically, if it's a capacitor, it would be like, oh, this is charging and this is discharging again. So forget about that part. We'll be discussing when we'll be discussing about capacitor or other things. So what I wanted to say, from this time interval to this time interval, this battery will be charged, because from this time to this time, we'll be getting the voltage which is actually greater than 10. So how will we calculate this thing? So here is the solution. This is the circuit. Don't need to draw the circuit. So what I have said, it's like this. So as we know, the omega and everything. So can you calculate what is the time here? What is the time here? I think you know the time, right? So what is the value here? 10, right? So if I substitute the value 10 equal, what is the maximum value? 15. What is the sine? What is the omega value? 377. What is the time here? T1, right?
1.
T1. Can we solve this equation and we can get the value for T1, right?
Yes, sir.
Yes, thank you so much. So can you calculate the value of T2 like similarly?
Yes, sir.
How? Can anybody answer? This is not a straightforward question, but can anybody answer?
Sir, 180 minus 377
But that will give me the angle.
Sir,
Your
0.11 second, I guess.
0.11 second. So in order to do so, I need to know what is
we
the
must-
actually time period. Can you calculate
we
time
must-
period here?
Yes, sir. Del T actually T2 minus T1 in order to actually find the.
So what is T actually? Just a second, I'll change some color.
Sir, it is 0.016.
Hey, do you have in the class after that? Does anyone have in the class after that? I may
Yes, sir.
actually take another
Yes,
5
sir.
minutes. Oh,
Yes,
then I will
sir.
actually finish. Okay,
Yes,
sorry.
Sir, it will be 0.016, the time period.
Okay, I don't know, the exact value, numerical value, but this is T, right? So what is this? T by 2?
T by 2.
So if we can calculate T here, so we can calculate T by 2 here. Look, whatever the value from here to here, it would be the same value here to here because it's a symmetric graph. So once I know T1, T2 would be nothing. T2 would be nothing but T by 2 minus T1. Do you understand this?
yes, sir.
Okay.
Yes,
One
sir.
more thing, so you will be practicing actually. What is the phase angle here and what is the phase angle here? For phase angle, if you calculate the phase angle here, means 377 times T1, this is the phase angle. The whole thing is the phase angle. This phase angle you don't need to actually calculate because this is 0, this is 180 degrees. So 180 degree minus alpha 1 that will give you the phase angle here. So answer is the workout is here. So maybe you can just check. The next thing we'll be actually discussing this sketching from the next class. So that could be for today. Do you have any question? Am I going so fast, or I'm a bit messy? Like I didn't actually arrange everything properly. It will take some time.
Sir, will you take the attendance now, or we'll write
Is it your
our
first
name?
class?
Yes, sir.
I don't take attendance. So, but from the next class, what you can do, you all can actually write down your ID on the chat box. So it would be my record. But I can assure if there is some mark for the attendance, you all will get the full marks. I don't care about attendance. But this is for my record only. Like if somebody asks me from the administration, I can actually tell them, oh, this students were present on that class. So this is just for the recruitment. Okay, you don't need to write today. It's fine. Have a actually nice day to be it, and I'll be actually uploading the Google today's actually class recording on Google Classroom. All right.
Sir, I have one question.
Yes, sure.
Sir,
Go ahead.
at one part in your lecture, you showed us a signal that you said that it was a AC signal but with a DC offset. So can you explain a little bit on that?
The time is over, but
I think the signal was like a
something
sine
like
wave.
this.
Yeah, a
Something
sine
like
wave
this.
with yes, sir, just like this.
So this is a sine wave, right? Because
Yes,
I
sir.
have a new reference point, but this new reference point is not a zero, because this is my real reference point time, right?
Yes, sir.
Like, but you see, this reference point is not zero. So what is the difference between the original reference point and the new reference point?
Sir, here
It's
the
2.
original reference point will be the axis,
2.
right?
So now check it out. Like this is T, and if I draw a line like this, what sort of signal is this? It's a DC, right?
Yes, sir.
So this one is nothing but the summation of two signal. One is the sinusoidal, which is called AC, means only that signal is AC. And now we are adding an offset that will give us a shift on the upward direction, on the rightward direction, and that is called the DC. So we have a DC part and then the AC part. So this is a hybrid signal. We'll be discussing it in the next next class probably.
Yes, sir.
Okay.
Thank you, sir.
Okay.
Thank you, sir.
Any more question?
No, sir.
I'm again saying, if you are not understanding any part or any terminology, because you are new to like university probably, maybe in second year or third year, I don't know which semester are you in. So if you don't understand anything, please raise your hand or ask me right away. I don't mind, even if you ask me the wrong question. Okay, thank you. Have a nice day. I will end it.
Thank you,
I will
sir.
end it.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Bye-bye.
Assalamualaikum, sir.
Walaikum assalam.
Sir, assalamu alaikum.
Walaikum assalam.
Assalamualaikum, sir.
Walaikum assalam.